Hello, I'm Maria, and I'm one of the investigators here to investigate the investigation. And so, we know that the car said that they were at a full stop, and we also know that they were 13 meters away from the collision, and that the truck driver didn't slow down. So, first thing we did, using the information that the tire company gave us, we figured out the mu, so the coefficient of friction. And after we got the coefficient of friction, we were able to figure out the friction caused from the car. Then, using the mu, we were able to find the friction of the car on the road. We use F is equal to ma to find out the acceleration after collision. And then we plug in the values into this next equation that will be able to help us find the velocity after collision. And then so for this equation, we plugged in the acceleration that we already knew because of the previous equation that we solved, and then the 8.2 was given to us to solve this problem. Next, we use the equation for the conservation of momentum to figure out the velocity before the collision of the car. And so this is a very difficult number. We knew the masses, and we knew the velocity after the collision because of the previous equation. And so we plugged in all of the knowns, and we ended up getting that the velocity, the initial velocity before the collision was 12.771 meters per second. So then we wanted to figure out what would have been the distance from the collision if the car had actually stopped. And so we used the v squared is equal to v0 squared plus 2 times acceleration times the change in y equation. And we plugged in the velocity that we got from the previous equation. And it's equal to 0 because the initial velocity would have been 0 if it was at rest. The maximum acceleration was a given, and it was 3 meters per second squared, so we plug that in. And then we have our change in y, which we wanted to find. And we got the change in y was 27.178 meters, and that is not 13 meters away from the collision as the car said, so the car was not at a full stop.
I'm Sophia, and I was one of the investigators who was investigating the truck. So what the truck driver said was that the truck was braking before the collision, as it had a flashing yellow light, which means you have to yield, and that the car driver did not stop, and that the truck was going 6.7 meters per second at the point of impact. So we investigated to find out if that was true or not, and if he was at fault. So we started off with the mu, which we know was that the truck had 70% of the mu of the car, which was given to us. So we took the mu of the car, which is 0.769, and multiplied it by 0.7 to get 0.538. And then we took that mu and plugged it into our equation, mu equals friction over normal force. We got that friction was 37,498.6 newtons. Then we did the F equals ma formula. Then we got the acceleration of the truck after the collision was 5.272 meters per second squared. Then we took that acceleration after the collision and we plugged it into our v final squared equation. We plugged in all our values to get the v initial, which would have been the velocity after the collision, and that was 10.768 meters per second. We plugged it into our conservation of momentum equation, and we got that the velocity of the truck before the collision was 12.504 meters per second. And from that, we concluded that the truck was going almost twice as fast as he said he was going. He said he was going 6.7 meters per second at the point of impact, but in reality, he was going 12.504 meters per second. So he lied about that. But we concluded that the car driver was more at fault because the car driver didn't stop at all when he had to stop because of the flashing red light, and the truck driver only had to yield. So the car driver was more at fault.